Next part of this chapter deals with quadratic growth. So we've got a quadratic function. The graph, as I'm sure you're aware, will look like one of two things. It'll either look like a happy, cheerful quadratic, and that shapes what's called a parabola, or it'll be quite a grumpy one. Now, what tells you if it's happy or sad is the coefficient of x squared, this a value. If a is positive, it's happy. If a is negative, it's sad. Other things that we know from the quadratic graph, plus c straight away. That tells us where it crosses the y-axis. Where it crosses the x-axis, those are called the roots. The solutions, the input values that give you a zero answer. So those are the roots. And would solve a quadratic by factorising, setting equal to 0, completing the square, setting equal to 0, quadratic formula. You've got three ways of doing that. This point here and this point here is known as a turning point. This would be the minimum point, this would be the maximum point. If you've got more than one, it'd be a minima, maxima. Now, to work out the minimum point or the maximum point, you could firstly use basic symmetry properties. The x value must be directly in between the average of the two roots, and then you'd substitute that value back into the equation to work out the y value, or you complete the square. If you complete the square, that will tell you the coordinates of the turning point. Let's look at example now. Example 11. Example 11 would like us to sketch the graph of y equals x squared take away 5x plus 4. So straight away we know it's going to be a happy graph. We know it's going to cross the y-axis at 4. Let's work out where it crosses the x-axis. It crosses the x-axis when the function equals 0 and y equals 0, because along the x-axis the value of y is 0. So x squared minus 5x plus 4 equals 0. Does it factorise? Times together to make that, add together to make that. They've both got to be negative because it's the only way of getting those signs. Minus 4 and minus 1. So my two solutions would be x is 4 and x equals 1. Those would be the roots. Those are where it crosses the x-axis. It looks somewhat similar to that 1 and 4. Okay, what about the minimum point? Now, I can work out the minimum point by looking at what's in between 1 and 4, 2.5, substitute 2.5 back into here, and you'd get the y value. But a more common method is to complete the square. So if we complete the square, just look at this part first, bracket, bracket, squared, got to be an x, got to be a takeaway. Slightly more awkward because half of 5 is 5 over 2, then you square that, 25 over 4 plus 4. Now, in order to combine these two, we need to make that a fraction where 4 is the denominator, 16 over 4. So that'd be x, take away 5 over 2 squared, and then I've got 16 quarters, take away 25 quarters, which would be minus 9 quarters. So, now to work out the coordinates of the minimum point, remember, this bit has to be bigger than or equal to 0 because we square it. So when this is equal to 0, the smallest this could possibly be is minus 9 over 4. When does that occur? Well, that occurs when the bracket is equal to 0, which would be when x equals 5 over 2. So those would be the coordinates of the turning point, the minimum point. So we can do that really quickly. This bit will always be the y value, and whatever makes the bracket equal to 0 will be the x value. So putting all those facts together, the graph would look something like this. Crosses the y-axis at 4, crosses the x-axis at 1 and 4, and the coordinates of the turning point is 5 over 2 minus 9 over 4. Okay. On to example 12. This time I need to sketch the graph of y equals 4x minus 2x squared minus 3. Well, first let's write it in the preferred order. Minus 2x cubed plus 4x, take away 3. So, well, that's meant to be a squared, sorry, not cube. So, firstly, negative 2, we have a sad quadratic on our hands. It's going to cross the y-axis at minus 3. So it may look something like that. We need to work out its roots. Where does it cross the x-axis? So if I said minus 2x squared plus 4x, take away 3 equals 0. Now, I don't like solving quadratics where the coefficient of x squared is negative. So what I can do is just bring them all over to the other side. Effectively, all the signs will change, giving me 2x squared minus 4x plus 3 equals 0. It's just a little bit easier to solve. Okay, now I'm going to solve this by completing the square. No, actually I'm going to solve it using the quadratic formula. So a equals 2, b equals minus 4, and c equals 3. Remember the quadratic formula? Minus b plus minus square root of b squared, take 4ac, all divided by 2a. So putting those in, minus b, minus 4 is 4, plus minus square root b squared, minus 4 squared is 16, minus 4 times a times c, all divided by 2a. So 2 lots 2 is 4. So let's work out the bit under the square root. 4 times 2 times 3 is 24. 16 take 24 is minus 8. Now you probably know there we've got a problem. If you try and do that in your calculator, it'll say error. Reason being, you can't square root a negative. Well, you can, but you won't get a real solution. You get an imaginary solution. So there are no solutions. There are no solutions, no roots, which means it doesn't cross the x-axis. So the x-axis wouldn't be there, it'd be above it somewhere. We can though work out the turning point, which in this case will be a maximum. So if we go back to our equation and try to complete the square. In this case, we could only use this method because we don't know where it crosses the x-axis to have a line of symmetry. So we've got minus 2x squared plus 4x, take away 3. I'm going to just look at this part, and the first thing I'm going to do is bring the minus 2 out. And make it minus 2x squared minus 2x. Minus 2 times x squared is minus 2x squared. Minus 2 times minus 2x is 4x. Now if we complete the square just on this part, so it's going to be a bracket, bracket, squared, minus, going to be an x, going to be a minus, halve it 1, square it 1. I now need to bring the 2 back in by multiplying both of these parts by 2. So giving me minus 2 brackets, x minus 1 squared, plus 2, because minus 2 times minus 1 is plus 2, take 3. That's minus 2, x minus 1 squared, minus 1. That's quite a difficult one, that. Now, in terms of the maximum point, the smallest this could ever be is 0, so the smallest this could ever be is 0, so the smallest this could ever be is minus 1. Now, but think about the other way. What we're doing here is this can only ever be bigger than or equal to 0. So when you times it by minus 2, this is actually always going to be smaller than or equal to 0. So this is always going to be smaller than or equal to minus 1. And that's going to occur when the bracket's 0, when x is 1. In terms of finding the coordinates of the turning point, in this case the maximum, it's exactly the same thing as before. Minus 1, what makes the bracket equal to 0? 1. Just drop that down. What makes the bracket equal to 0? So bringing all that together, we've got a maximum point at 1 minus 1, crosses the y-axis at minus 3, and that's, you don't know where it crosses the x-axis. minus 3, 1, minus 1. Okay. And that's all the questions up to exercise 2F.